Hello dear students, welcome back to the next session of number systems. In this session we are going to solve the problems in the exercise 1.3. I hope that you all practiced all the concepts whatever we learned in the previous session. This figure illustrates how to classify the given number as a rational number or irrational number. We know that rational number is a number whose decimal expansion is terminating and non-terminating recurring. The example 1 by 5 is equal to 0.2. It contains the finite number of digits and remainder as 0, hence it forms a terminating decimal. In the second example, 1 by 3, which is equal to 0.666, it never terminates and it has a repeating pattern, hence it forms a non-terminating recurring. So we can conclude that these two examples are called as rational numbers. Then we can go for irrational number. An irrational number whose decimal expansion is non-terminating and non-recurring. I had given two examples. Root 2 is equal to 1.414 etc. and 0.1231234 etc. In these two examples, you can see the decimal expansion never terminates as well as never repeats. Hence, we can conclude that these two example forms an irrational numbers. Students, here I had given few examples to represent the rational numbers. The first example 7 by 8, the result obtained as 0.875, which contains finite number of digits and the remainder as 0, hence it forms terminating decimal. In the second example 10 by 3, the result obtained as 3.333, which contains infinite number of digits and as a repeating pattern, hence it forms non-terminating repeating decimal. The third example, 1 by 7, the result obtained as 0.142857. Students, please don't conclude by seeing the numbers which never terminates as well as never repeats. It forms an irrational number. You have to continue the division process up to the value given in the divisor. For example, your divisor is 7. You should proceed your division process up to 7 decimal places. In the 7th place, if the digit is not repeated, you can conclude that it is an irrational number. If it repeats, it forms an rational number. This is very important thing for a proper fraction. You have to follow this concept. Definitely you have to see this concept. According to this concept only, you have to continue your division process and check whether it forms a rational number or irrational number. An example of an irrational number. We know that how to calculate the square root of 2 by long division method, which we learned in the previous class. While doing the long division, we got the result as root 2 is equal to 1.4142135623. It goes on, keeps going on. So in this pattern, the decimal expansion, the number never terminates as well as never repeats. So we can conclude that the decimal expansion of root 2 is non-terminating and non-recurring. It forms an irrational number. Let us start the exercise 1.3. First question. Write the following in decimal form and say what kind of decimal expansion each has. First question, 36 by 100. The result obtained as, while dividing 36 by 100, we are getting the result as 0.36. This decimal expansion contains finite number of digits as well as the remainder as 0. Hence, we can conclude that this decimal expansion forms terminating decimal. The second question, 1 by 11. While dividing this 1 divided by 11, we are getting the result as 0.090909. It goes on, keeps going on. That means it never terminates as well as it has a repeating pattern. Hence, it forms non-terminating and repeating decimal. Second question in the exercise 1.3. You know that 1 by 7 is equal to 0.142857. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 6 by 7 or without actually doing the long division? If so, how? Solution. Already in the question they gave 1 by 7 is equal to the value of 1 by 7, which is equal to 0.142857. To find out the value for 2 by 7, 3 by 7, 4 by 7 and 6 by 7 without doing the long division, you should do the calculation in this way. Just multiply 2 by 7. Just write 2 by 7 in terms of 2 into 1 by 7, which is equal to 2 into 0.142857, which gives the result as 0.285714. The same manner you can do it for 3 by 7, 4 by 7, 5 by 7 and 6 by 7. That is 3 by 7, which is equal to 3 into 1 by 7, which is equal to 0.428571. 4 by 7, which is equal to 4 into 1 by 7, which is equal to 0.571428. 5 by 7, which is equal to 5 into 1 by 7, which gives the result as 0.714285. At last, 6 by 7, which is equal to 6 into 1 by 7, gives the result as 0.857142. Third question from exercise 1.3. Express the following in the form of p by q, where p and q are integers and q is not equal to 0. X is equal to 0.6 bar. Let x is equal to 0.6 bar, which can be written as 0.666, etc. Take down as first equation. Students, please check in the expansion how many digits are repeated. If only one digit is repeated, multiply the equation by 10. 2 digits means 100 and 3 digits means you have to multiply the expansion by 1000. So here only one digit is repeated, so you have to multiply this equation by 10. Hence, so you can multiply the equation both the sides by 10. We get the result as 10x is equal to 6.666. To convert this expansion into p by q form, you have to subtract the equation 1 from second equation. So while subtracting the first equation from second equation, we got the result as 10x minus x, which is equal to 6.666 minus 0.666. While simplifying, we got the final result as x is equal to 2 by 3. Second question, x is equal to 0.47 bar. Here only one digit is repeated. We can write x as 0.47 bar, which is equal to 0.4777, etc. Consider to be the first equation. Since only one digit is repeated, so we can multiply that equation 1 by 10. We get 10x is equal to 4.777, etc. Name it as second equation. And see the decimal expansion of first and second equation. The decimal expansion, while subtracting the decimal expansion, you will not get the whole number part, integral part. So once again you have to multiply that second equation by 10. We get 100x is equal to 47.777. Now you can see the decimal expansion of second and third. While seeing if you are getting the similar decimal expansion, then you can stop proceeding that multiplication and you can subtract that equation second from third equation. While subtracting the equation 2 from third equation, 100x minus, we get 100x minus 9x is equal to 47.777 minus 44.777. While simplifying, we got the result as 90x is equal to 43, where x is equal to 43 by 90. Hence, we conclude that 0.47 bar can be written as 43 by 90. Fourth question in the exercise 1.3. Express 0.9 bar in the form p by q. Are you surprised by your answer? With your teacher and classmates discuss why the answer makes sense. Solution for this question. Let x is equal to 0.9, which is equal to 0.9 bar. Here we have only one repeating digit, so we multiply both sides of this first equation by 10 to get 10x is equal to 9.999. Consider to be the second equation. Subtracting 1 from 2, we get 10x minus x, which is equal to 9.99 minus 0.99, which gives the result as 9x is equal to 9. While simplifying, we got the result as x is equal to 1. Hence, we can say that 0.9999, which is equal to 1. Since 0.99 goes on forever, so there is no gap between 1 and 0.9 bar. Hence, they are equal. Fifth question from exercise 1.3. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Solution for this. While doing the division process, we got the result as x is equal to 0.0588235294117647, etc. I told you before in the previous question how to calculate 1 by 7. You have to continue the division process up to the value of divisor given. Here divisor is 17. So continue the process up to 17 decimal places and check whether it repeats or not. In the question already they given it as a repeating block of digit. We have to calculate only the maximum number of digits in the repeating block of digits. So in the 17th place it's again started repeating. Hence we can conclude that the maximum number of digits in the quotient while computing 1 by 17 are 16. Students, go through all these questions from this exercise and practice it. Thank you.